So let's talk about water soluble vitamin, that is vitamin B1. Vitamin B1 also called thiamine, and thiamine has a role in key role is involved in the metabolism of leucine, isoleucine and valine. Thiamine has a central role in energy yielding metabolism. Thiamine has a central role in energy yielding metabolism, and especially the metabolism of carbohydrates. Thiamine diphosphate is the coenzyme for three multi-enzyme complexes that catalyze oxidative decarboxylation. Thiamine has a central role in energy yielding metabolism, and especially the metabolism of carbohydrates. Thiamine diphosphate is the coenzyme for three multi-enzyme complexes that catalyze oxidative decarboxylation reactions: pyruvate dehydrogenase carbohydrate alpha ketoglutarate dehydrogenase citric acid metabolism, and branch chain keto acid dehydrogenase involved in metabolism of leucine, isoleucine and valine. So thiamine has a central role in energy yielding metabolism, and especially the metabolism of carbohydrates. Thiamine diphosphate is the coenzyme for three multi-enzyme complexes that catalyze oxidative decarboxylation reactions: pyruvate dehydrogenase in carbohydrate metabolism, alpha ketoglutarate dehydrogenase citric acid metabolism, branch chain keto acid dehydrogenase involved in metabolism of leucine, isoleucine and valine. In each case, the thiamine diphosphate provides a reactive carbon and the thiazole moiety that forms a carbanion, which then adds to carbonyl group. Example, pyruvate. The addition compound is then decarboxylated, eliminating carbon dioxide. Thiamine diphosphate is also the coenzyme for trans-ketolase and the pentose phosphate pathway. Thiamine triphosphate has a role in nerve conduction. It phosphorylates and so activates a chloride channel in the nerve membrane. So thiamine has a central role in energy yielding metabolism, and especially the metabolism of carbohydrates. Thiamine diphosphate is the coenzyme for three multi-enzyme complexes that catalyze oxidative decarboxylation reactions: pyruvate dehydrogenase in carbohydrate metabolism, alpha ketoglutarate dehydrogenase in citric acid metabolism, and the branch chain keto acid dehydrogenase involved in metabolism of leucine, isoleucine and valine. In each case, the thiamine diphosphate provides a reactive carbon on the thiazole moiety that forms a carbanion, which then adds to carbonyl group. Example, pyruvate. The addition compound is then decarboxylated, eliminating carbon dioxide. Thiamine diphosphate is also the coenzyme for trans-ketolase in the pentose phosphate pathway. So thiamine has a central role in energy yielding metabolism, and especially the metabolism of carbohydrates. Thiamine diphosphate is the coenzyme for three multi-enzyme complexes that catalyze oxidative decarboxylation reactions. So in oxidative decarboxylation reaction, thiamine diphosphate is the coenzyme. So what are the three oxidative decarboxylation reaction? Pyruvate dehydrogenase in carbohydrate metabolism, alpha ketoglutarate dehydrogenase citric acid metabolism, and branch chain keto acid dehydrogenase involved in metabolism of leucine, isoleucine and valine. So in each case, the thiamine diphosphate provides a reactive carbon on the thiazole moiety that forms a carbanion, which then adds to the carbonyl group. Example, pyruvate. The addition compound is then decarboxylated, eliminating carbon dioxide. Thiamine diphosphate is also the coenzyme for trans-ketolase in the pentose phosphate pathway. Thiamine triphosphate has a role in nerve conduction. It phosphorylates and so activates a chloride channel in the nerve membrane. Thiamine deficiency can result in three distinct syndromes: a chronic peripheral neuritis, beriberi, which may or may not be associated with heart failure and edema; acute pernicious fulminating beriberi; Shoshin beriberi, in which heart failure and metabolic abnormalities predominate without peripheral neuritis; and Wernicke encephalopathy and Korsakoff's psychosis, which is associated especially with alcohol and narcotic abuse. The role of thiamine phosphate in pyruvate dehydrogenase means that in deficiency there is impaired conversion of pyruvate to acetyl-CoA. In subjects on a relatively high carbohydrate diet, this results in increased plasma concentration of lactate and pyruvate, threatening lactic acidosis. associated with especially with alcohol and narcotic abuse, Korsakoff and Wernicke's encephalopathy, and lactic acidosis. That is life threatening. Okay.